Assalamu alaikum. In this video, we'll discuss refraction in a glass slab. Now, before going ahead, let me tell you what is refraction. Refraction is the phenomenon of deviation of light when it enters from one medium to another medium. Now, to discuss refraction in glass slab, I consider a glass slab of a thickness T. Let us consider this one as a glass slab whose thickness is a T. Now, let us take for example a ray of light incident at this end of the glass slab. As I told you earlier, light always deviates when it enters from one medium to another medium. This slab is made of glass whose refractive index is taken as N2 and placed in air. Here it is made of glass and placed in air. So when the light enters from air to glass, it will deviate. Actually, without deviation, it has to travel in this manner. This is the direction of light without a deviation. But due to deviation, it bends towards the normal. Here, this is the normal. It bends towards it. Then at this end, it comes out. Now here I draw one more normal. See, when light enters air from glass, it again deviates. Now the deviation is away from the normal. It is away from the normal. Okay. Now let me make it a little thick. So here the light which has come out after refraction through the glass slab goes parallel to the ray of light which has come out without deviation. This is undeviated ray, this is a deviated ray. You can see these two are parallel to each other but separated by certain gap. Now this gap actually represents a lateral displacement. Here, to find this lateral displacement, I draw a perpendicular to this line, to the refracted ray. This perpendicular line to the refracted ray provides me the lateral displacement whose length is L. Whose length is L. Okay. Now, with respect to this normal, I name this as normal N1 and this normal is named as N2. With respect to normal N1, I find the incident angle, which is nothing but I, this angle of incidence with respect to normal. And here, this one, the angle between a refracted ray and the normal is taken as angle of refraction. Reference letter small r. Now, here, one thing you need to know. This angle between undeviated ray and the normal is taken as I. This angle is taken as I, which is nothing but angle of incidence. Clear? This in accordance with the geometrical rules. Fine. Now, what about this angle? What is this angle? The angle between deviated and undeviated ray is nothing but I minus R. This angle is I minus R. Clear? Now, here by keeping the same thing in mind, if this angle is R, then this angle will also be R, angle of refraction. Clear? Now, let me name this ray of light as A, B, C, and D. Okay, it travels in this direction. Travels in this direction. Here, ABCD is a ray of light which has traveled through the glass slab. Okay. Now, I am going to find out the value of N. Here, to do so, first I take a sine of angle I minus R. Now, in a triangle, actually, I take a triangle, in a right angle triangle, BC. I name this E, this point, and this point is named as F. I take that right angle triangle BCE. In right angle triangle BCE. Sine of angle I minus R is obtained as opposite side divided by hypotenuse. Okay, what is opposite here? Opposite to I minus R is nothing but CE. CE divided by hypotenuse. What is the hypotenuse? It is nothing but this BC. This hypotenuse BC. We know the value of C from the diagram, which is nothing but L. Okay. Sine of I minus R. Here the value of C is L divided by BC. Now from this I am going to get the value of BC. What I will get? BC is taken this side and this term will come to the denominator. BC is equal to L upon sine of I minus R. This is what I get. I box this one for better visibility. I name this one as equation number 1. Okay. Here L is the lateral displacement, I is angle of incidence, and R is the angle of refraction. Got it? Now I am going to get the cos of R. For that I will choose a triangle. I will take this right angle triangle BCF. BCF. I will take a right angle triangle BCF. Right? Let's see, what is this? Here, cos of this angle is nothing but adjacent side divided by hypotenuse. What is the adjacent side here? It is nothing but BF. The adjacent side is BF and hypotenuse is nothing but BC from the diagram. BC. Okay. Here, from the diagram, we know the value of BF, which is nothing but T, which gives the thickness of the given slab. Okay. So cos of R is nothing but T divided by BC. So again, from this equation, I am going to get the value of BC. It is taken that side, and brought down. Yeah. So what I'll get, BC becomes equal to T upon cos of R. Now I'll box this for better visibility. Okay, and it is taken as equation number 2. Now if you compare equation number 1 and 2, you may find that both of them have got the same term on the left hand side. Okay, so comparing equation 1 and 2, what do you get? We witness. So when the same term is present on the left hand side, it means the right hand side term of equation 1 will be equal to the right hand side term of equation number 2. Clear? So we can write it this way: L upon sine of I minus R equals to T upon cos of R. Clear? From this, the value of L is equal to, this lateral displacement is equal to, here this is kept as such, T upon cos R is kept as such, and this term is taken to the right hand side. It is a denominator. When it is taken to the right hand side, it will multiply, it will go to numerator. So here it is sine of I minus R. Okay, this is what we get at the end. Here from this final expression, we understand that lateral displacement L, here L is a lateral displacement, which is otherwise referred as shift or a shift. Now it is the gap or the displacement between undeviated ray and the deviated ray. Clear? So L is found to be depends on three things. First, it depends on thickness of the glass slab. Second, it depends on the refractive index of the medium of which the glass the slab is made of. Refractive index is represented by N. Third, it depends on here T stands for thickness of the slab, represented by T. And third, it depends on the angle of incidence. Angle of incidence. Angle of incidence is represented by letter I. On these three things, the lateral displacement depend. So if we increase the value of a thickness, if we increase the thickness of the slab, automatically what will happen? L value will increase. With the increase in thickness of the slab, lateral displacement will increase. The same thing happened with the refractive index. When the refractive index of the slab is increased, refractive index of the medium of the slab is increased, in such case the refraction will increase. Here deviation, light will deviate more. Okay, so when the refraction increases, automatic it will result in the increase of L value. With the increase in N value, L value will increase. The third thing, when we increase the angle of incidence, here if it bends little more towards the slab, that means we increase the value of I. When we increase the value of I, with increasing the value of I, L value will increase. Okay, when I value increases, L value will increase. This is what we understand from this equation. Clear? I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your question in the comment section. Thanks for watching.